Hi, this is James, and welcome to a new episode of DoYouMQ. DoYouMQ is a podcast where we discuss enterprise messaging and interview IBM MQ experts to share their insights and knowledge on the vital role of message queuing in today's world. Today I'm joined by Mark Taylor, an IBM MQ ecosystem developer. Hi Mark, thanks for joining us today. I really appreciate it. I was hoping we could start off by talking about MQ's overall approach to monitoring and where you are involved within that.
Okay, sure, thanks. One of the central goals of MQ ever since its original inception was to be able to work wherever you need it to. And you could see that clearly in things like the operating system support and the variety of programming languages for writing applications. But it's also always been true for managing and monitoring of the product. We wanted MQ to be able to be observed and controlled from a variety of tools. So we designed general mechanisms that could be used by anyone. We didn't want to have a specific MQ product-owned tool. Things have certainly changed over the years in regards to the details of what information is available, but that fundamental has remained, allowing the monitoring solutions to evolve along with MQ itself. I think the last major extension to the monitoring produced by MQ in terms of patterns and styles was when we started to publish the resource metrics, and that came in all the distributed platforms at version 9.0. Most of MQ's monitoring data is produced in a binary format known as PCF, programmable command format. There was no common format when MQ was first created, and this self-describing pattern was invented to make it relatively easy for programs to be written to work with that format. If we were starting again today, I expect we wouldn't use PCF and would instead use JSON. And I'll talk more about JSON later as we've done various integration options with JSON processing. But I think at least one good thing was we managed to avoid doing anything at the time when XML was flavor of the week. As for my own experience, I've added a few monitoring features to the MQ base, including creating and extending various event messages. But my main involvement has come from writing tools that make use of and demonstrate the features. And that's included things as varied as writing plugins for the MQ Explorer, processing ZOS SMF records, and in recent years creating tools that can take metrics out of the queue manager and get them into solutions such as Prometheus and Grafana. I've talked to a number of the monitoring product vendors to show them what can be done and how, and which pieces are most useful. And then, of course, I spend a lot of time talking to users about what can be achieved and demonstrating those capabilities.
I was wondering if you were going to be talking about any particular monitoring products?
No, not really. I've often been asked what's the best monitoring product for MQ, and my standard answer is that it's whatever you are already using to monitor other things, which might be looking at ZOS subsystems, or it might be looking at operating systems or databases or app servers or any of the other myriad of components that make up your infrastructure. A while ago, and I think it was probably about 10 years, I was asked to investigate what admin tools were available for MQ. That covered both monitoring and configuration solutions. I very quickly found about 40 tools, some enterprise scale, some much smaller with a specific focus. Since then, some of those tools sort of disappeared or been merged with others or been rebranded. And of course, there's been many more introduced since, especially with the explosion of cloud environments and of open source components, newer ways of deploying and using both MQ and the rest of your stack. But it's probably fair to say that whatever monitoring tools you have, there will almost certainly be a way to slot MQ in. Just today, I was sent a question related to a monitoring product I'd never previously heard of, but which is working with MQ metrics. If you have no current monitoring solution, then I'm sure the IBM sales reps would love to discuss Instana with you. But I'm not going to try and push that any further here. Instead, I'm going to try to remain neutral, although I'm probably going to mention some of the tools I've worked on or with as examples. What's really important is that you have something.
Without leaning towards one option or another, what are people looking for with their monitoring, would you say?
I think there are several things that people want to achieve with monitoring, several large sort of buckets of requirements. The first thing is that they want to know when something has gone wrong and to have enough information to be able to resolve it. Then there's keeping track of items of interest. That might be, for example, looking at how applications behave or keeping an audit trail. Then there's trying to stop potential problems before they cause a real impact. And that in turn can be broken down into both a short-term and a long-term view. A short-term item might be recognizing that a queue is 80% full, and unless something is done about it, it will fill up in 10 minutes, and that could bring down your processing. As a long-term example, I want to see how messaging traffic is increasing week by week in order to plan for hardware upgrades or a reallocation of resources. Alongside that, people will usually want to integrate their MQ monitoring with other pieces of the environment so that they can see overall application information where an application is broader than just a single program. It might be referring to an entire business flow. They want to see that as well as just the MQ aspects. A Kix transaction, for example, might not be responding in time because an MQ channel 3 hops away has been stopped. Problem determination and resolution is a huge topic. Having effective monitoring is certainly a piece of managing that. And without wishing to preempt other episodes in this podcast series, I think there's probably scope for a separate podcast going into further aspects of problem determination, such as looking deeper into application behavior.
So Mark, what does MQ produce to help people monitor their systems?
There are several types of data, and I bracket them into logs, events, status, and what I'll broadly call statistics. And we'll drill further into those later on. Starting with the log messages, as they're probably the first things people see. They're probably the first things you look at when you need to understand what's going on in your system. They're a very different style from just about everything else that the queue manager produces. And the logs I'm talking about here are what have traditionally been called error logs, and not to confuse them with the transaction or recovery logs that the queue manager also maintains for transactional state. On the distributed platforms, we would prefer to call these logs diagnostic service logs. So they've always contained more than just error reports. But the fact that they have in the file names doesn't really help us move away from the name. On ZOS, the equivalent is usually known as the JES log. These logs can contain a mixture of status reporting, for example, showing each of the queue manager's internal tasks as they start up, and a level of detail around various kinds of errors, such as an authorization problem. Each entry in the logs on the distributed platforms has a common set of header information, timestamps, version numbers, queue manager name, and so on. Then there's the specific message written in a readable format with variable parts of the message, like the name of a queue, filled in. And the message also has a severity indicator, which might be part of any initial filtering you want to apply. Show me only the items that are at a warning level or worse. The biggest enhancement that's come in recent years to these logs is the option to have them also created in JSON format. That makes it much simpler for tools to consume the records rather than relying either on a real person reading them or by using various cutting and scraping techniques to parse the messages out of the logs. Using JSON also means you don't have to have a dedicated MQ-aware component to read those messages. There are lots of generic tools out there designed for handling log files of many kinds, including JSON, for example, the ELK stack. And that can take those logs in the same way as they take logs from other products, and maybe merge them, do filtering, doing aggregation, all of the kinds of things that you might want to do to work with that kind of data from a range of products. Status information from MQ is typically the information that a monitoring tool will poll for every minute or 5 minutes or whatever you've chosen as an interval. The monitor will ask the queue manager for the status of various resources. It's different from, I think, just about all the other information sources in that it's a pull model. You ask for it to be given to you rather than a push of some kind where the queue manager asynchronously writes or generates the data. For example, the monitor might issue the equivalent of display channel status to get a list of all the currently active channels and work out how quickly messages are moving through the channel. Or it might issue an alert if no traffic has been seen for 5 minutes. Most of the object types in MQ have associated status information, but the main ones that you'd be interested in are going to be on queues, topics, and channels. On distributed platforms, there's also an explicit display queue manager status command. On ZOS, a lot of the same information can be derived in other ways from the environment. Events are messages, regular MQ messages, generated by the queue manager, written to queues in the same way as application messages. Events are a notification that something has happened that you may want or need to know about. Some of these events are real alerts. For example, a queue's getting full, or worse, has already filled up. And some more of them would fit into what I've called an item of interest. And that doesn't mean they're unimportant, but it tends to mean you don't need to look at them right now. So things like command and configuration events are interesting. They often need to be captured because people are interested in audit trails of who made configuration changes. And those can, of course, be important, but they don't have that real-time aspect. Authorization failure events are probably somewhere in between the queue filling and the command events. If you get a lot of them in a short time, it might indicate a break-in attempt. But more commonly, they're something that an administrator would review with an application owner to resolve why the application is not authorized to use a resource in the requested fashion. Perhaps the app is asking for more privilege than it actually needs, or it's been misconfigured to use the wrong queue name. Maybe the app's been deployed before the administrator has had a chance to make the configuration changes that the app needs. Another sort of interesting event would be reporting on all the API calls made by an application. And that's useful for debug, helping sure the app is well written and so on, and fits more into the general problem determination space than regular monitoring. The final kind of data is a broad class of statistics. These are produced in a number of formats and they're enabled with different options. But these reports can tell you about the overall behavior of a queue manager, how many messages in total have been put in an interval, perhaps, about an individual object, such as a queue, how many messages have gone through that queue, and indeed about an application, how many messages has an instance of a specific application processed. On distributed platforms, these reports are made either by the queue manager writing a message to a well-known queue, or by a monitoring tool subscribing to topics that correspond to the information. On ZOS, they're integrated into the platform's standard reporting mechanism, SMF. These statistics can be used for long-term planning because they enable you to see trends, but they are also very helpful for analyzing your current environment, potentially making improvements like reallocating resources or changing how the applications behave.
Hypothetically, if I'm a queue manager administrator Is there anything I should configure on the queue manager for monitoring?
Yes, definitely. Many of the defaults on a queue manager mean that a lot of the status information is not made available without doing some configuration. There's very little cost in turning them on. I mean, a lot of the data that turns up in status reports is being captured internally anyway. So I would always recommend turning on the various mon and stat attributes on the queue manager. Things like mon channel and stat MQI, there are about half a dozen of those attributes. On ZOS, you should always be capturing the SMF 115 records. Again, there's very little cost or record volume involved in doing that. Most of the queue manager events, like authorizations or performance events, should also be turned on. But if you turn on those events, then you've got to make sure you do have a monitoring program running that's going to pull the events from the queue, because otherwise you'd end up with the monitoring queue filling up. Some of the other events, like command and config events, may be appropriate for auditing purposes. Some of the more verbose statistics and accounting events may be things you only turn on occasionally. Though again, I think you need to review what you actually want to achieve in your monitoring, how granular you want to get to, whether you're interested just in an overall health of the system, or whether you really do want to drill down into what all of the individual applications are doing as well. I do like the publish-subscribe approach for metrics on the distributed platforms, because then with those, there's nothing to configure at all on the queue manager. Just starting up a monitoring tool causes the data to be produced automatically. And you can have multiple consumers of the same data very easily. Perhaps you've got an enterprise level monitor looking at every queue manager across the entire estate, alongside a more local team specific monitor that's only interested in one or two queue managers. With mechanisms like pub/sub, both can get the information without interfering with each other and without requiring more complex configurations to try and keep the things isolated. One of the things I found when I was writing tools to demonstrate how to feed databases such as Prometheus and Influx with DoYouMQ metrics was, I started with just using those pub subtopics and metrics, but to be really useful, they did have to be merged with the status information coming back from the queues and the channels. Fortunately, getting status information also doesn't interfere with other monitoring tools. So again, you can have multiple collectors of status information. I was quite pleased when I was able to do a demo of 4 completely different back-end databases simultaneously being fed the same data from the same queue manager by different instances of a monitor program, and being able to show that there were identical graphs in Grafana dashboards all at the same time.
Many users may feel that being able to respond rapidly to status changes and issues is important. What can MQ do here?
It's absolutely true that there's a requirement around being able to get rapid access to data. Given the performance that MQ can achieve, it may not be very long, seconds perhaps, between seeing an alert that the queue is 80% full to it actually being full and no longer accepting messages. So you've got to have ways of seeing that that's happening and responding very rapidly. I think there's been a bit of a transition over the years between historic data capture and review and the rapid online viewing of status. I suspect we've seen polling times reduced. Where previously a monitor might poll for status every 10 minutes, now it's come down to perhaps every minute or less. The pub/sub resource metrics are produced every 10 seconds by default. I think the biggest change in this area that we've seen has actually been on ZOS, where the operating system was enhanced to allow tools to capture SMF data, those critical metrics, in real time, rather than how they'd been used in the past, where they are captured and then analyzed a day or more after production. And we've made corresponding changes in MQ to produce those SMF records at much shorter intervals if you want it. So again, rather than having a typical interval of 10 minutes, you can now tune it down to the seconds if you really want to. I saw a very good blog post recently by Tony Sharkey, where he was able to capture SMF data from a queue manager, have it formatted, and then fed to a graphing tool to show live traffic through the system. And it was all done with either product or operating system provided components or free tools.
Are there any key metrics that you feel people should be taking a look at?
I think that probably the most important metrics are the number of active channels and the depths of queues. Active channels might tell you a lot about how many applications are connected to your environment. You should also be able to see whether channels that you expect to be running, perhaps to other queue managers, are up or down. So that's a key status and metric that you have. Depths of queues, clearly you want queues to be processed rapidly. It's often been said the best queue is an empty queue. Some of the status information that comes out of looking at queues will tell you things like how long messages are living on the queues on average. But the depth is critical, because if that builds up, you're likely to have something else going wrong in your environment that you need to work through to get those messages processed. On ZOS, there's buffer pool usage, which can be key for the performance of queues there. And on distributed platforms, if you're doing a lot of persistent messaging, then I/O performance is key. One of the metrics that comes out of the PubSub metric resources shows the disk latency. And if that gets too high, then there will be slowdowns in messaging. There's certainly many more metrics that you might want to look at, and knowing what problems you've had in the past can guide you to pick which numbers you ought to concentrate on. I think it's probably true that very few of the metrics from the queue manager are useless, but some of them are perhaps less helpful than they once were because of the way either the application patterns, system deployments have changed, or the design of applications has changed. So take a look at what your current environment problems might have been, and I'm sure we can find some metrics that can help you monitor the state of that system.
Throughout this podcast, Mark, you have mentioned JSON formats quite a few times. How does JSON fit in with monitoring?
As I said at the beginning, the vast majority of MQ's monitoring data is either requested or produced using the binary PCF format. There are many tools that have been developed over the years that know how to work with it. Indeed, the queue manager essentially internally is using PCF throughout it. It's not quite that, but it's close enough. So PCF isn't really going anywhere, but it is the core to how we produce and accept information. But there are lots of other tools that don't see specific support of MQ formats as being their core business. And lots of those tools are able to process JSON formatted data, whether it's analysis, creating graphs, making predictions. Lots of things get done in many different generic tools based on the fact that they're consuming JSON data. So we've been finding ways to work with that format. Some of the things we do are part of the core product, creating the diagnostic service or error logs in JSON format. The channel definition table can be written in JSON. It's not part of monitoring as such, but it's part of the overall strategy of having that format. Then we've got the REST APIs, including an admin interface that's equivalent to the MQSC interface, where both the inputs and outputs are in JSON. I probably wouldn't use the REST admin API as the basis of a full-blown monitoring solution because of the need to integrate with some other pieces that aren't directly natively in JSON. But if all you're doing is issuing occasional display status commands, then it's a very simple thing to script and parse. And indeed, I was talking to a customer just yesterday who's going to be doing exactly that. In other places, we have sample programs that can convert events into readable formats, including JSON. So that sample will take a lot of the PCF generated event format, read them, spit them out in JSON, which can then be fed on to other tools or fed back onto queues as text messages. So you might do other things with them. That JSON format gives us a text description, a text layout of the data. And I was showing a group of people today another example of a piece of these problem determination space rather than monitoring tooling. But the product provided component writes its information in English text, and I've done a variant that prints it out in JSON with, again, the idea that that can be automated and parsed much more readily. So that particular tool, hopefully I'll get that out on GitHub fairly soon, once a couple of other pieces of work have been completed. But I think that covers everything that I wanted to talk about on MQ's monitoring, the kinds of data we have, how we produce it, how you can consume it. Obviously, I'm always happy to have more detailed conversations with people if they want to go into detail, be an environment where we can see charts and examples and all those kinds of things.
Mark, thank you for coming on to the podcast today. This topic has been extremely thought-provoking, and your insights and knowledge have reinforced it greatly. I hope to have you on again to expand on any further topics.
Thank you, my pleasure. Hope to talk to you soon.